Our topic for today is about percent composition and chemical formulas. As discussed, the law of definite proportions suggests that any sample of a given compound always consists of the same elements in the same proportion by mass. This helps determine the composition of a compound or the relative quantities of each constituent element. The mass of each element in a chemical formula, as well as its percent composition in the compound, may be obtained. The general formula for calculating the percent composition of an element in a compound is given by percent A is equal to the atomic mass of A multiplied by the number of atoms of A in the compound over the formula or molecular mass of the compound multiplied by 100. The A in the formula is the element of interest. Let's have an example. Sodium carbonate is commonly used as an additive in the manufacture of glass or as water softener and neutralizer for chlorine in pools. It is commonly known as soda ash or washing soda. What are the percentages of each element in the compound? First, let's identify the atomic masses of each element. For sodium, it is 22.99 AMU. For carbon, it is 12.01 AMU. And for oxygen, it is 16.00 AMU. First, let's identify the formula mass of sodium carbonate. That is the atomic mass of sodium multiplied by 2 plus the atomic mass of carbon multiplied by 1 plus the atomic mass of oxygen multiplied by 3. Substituting the atomic masses of each element will give us 22.99 AMU times 2 plus 12.01 AMU times 1 plus 16.00 AMU times 3. That will be 45.98 AMU plus 12.01 AMU plus 48.00 AMU, which will give us 105.99 AMU. Applying the general formula for percent composition for each constituent element will give us, for sodium, 45.98 AMU over 105.99 AMU multiplied by 100 will give us 43.38%. For carbon, we have 12.01 AMU over 105.99 AMU multiplied by 100 will give us 11.33%. And for oxygen, that is 48.00 AMU over 105.99 AMU multiplied by 100 will give us 45.29%. The percent composition of all the elements composing a particular compound should always add up to 100%. Let's have another example. Tartaric acid, or C4H6O6, is naturally found in fruits like grapes and banana. It is used in the food industry as a leavening agent that gives a sour taste. Determine the percent composition of each element in the compound. First, identify the atomic masses of each element. For carbon, it is 12.01 AMU. For hydrogen, it is 1.008 AMU. And for oxygen, it is 16.00 AMU. Second step is to calculate the molecular mass of the compound. That is the atomic mass of carbon multiplied by 4 plus the atomic mass of hydrogen multiplied by 6 plus the atomic mass of oxygen multiplied by 6. Substituting the atomic masses will give us 12.01 AMU times 4 plus 1.008 AMU times 6 plus 16.00 AMU times 6. Applying the operation will give us 48.04 AMU plus 6.05 AMU plus 96.00 AMU. That gives us 150.09 AMU. Applying the general formula for percent composition for each constituent element will give us, for carbon, that is 48.04 AMU over 150.09 AMU times 100 will give us 32.01%. For hydrogen, we have 6.05 AMU over 150.09 AMU times 100 will give us 4.03%. And for oxygen, we have 96.00 AMU over 150.09 AMU times 100 will give us 63.96%. The percent composition of all the elements composing a particular compound shall always add up to 100%.